right, so here I want to do a couple more examples, more complicated examples of simplifying rational expressions. And again, where applicable, we're going to write the restricted domain in the simplified expression. So if there's any hidden domain restriction, we want to make note of that. Okay, so in this first expression, we have 2y squared plus 7y minus 15 divided by the quantity 4y squared minus 4y minus 3. Okay, so when we look at factoring those are a little more intimidating perhaps because they have the coefficient in front of y squared there that is something other than 1, right? So in those cases, I'm going to kind of make a little aside down here, and I'm just going to talk about how to factor some of these things. So if I have 2y squared plus 7y minus 15, and I'm trying to factor that, I want to multiply a and c together, right, because we've got the ax squared plus bx plus c. So 2 times negative 15 is negative 30, and then I'm thinking about factors of negative 30 that add to 7. And I would think about negative 3 and 10, right? So use those numbers to rewrite the middle term. 2y squared minus 3y plus 10y, right, minus 15. Okay, so I just rewrote the middle term with the negative 3y plus 10y, and then factor by grouping, right? So if you have take a y out from that first group, so we have y times 2y minus 3, and then down below, what can we take out of that? We've got 5 times 2y minus 3, right? Now, 2y minus 3 is common to both of those terms, so factor it out. Sorry. Okay. So we have 2y minus 3 times the quantity y plus 5, right? Okay. So we have 2y minus 3 times the quantity y plus 5. That's the numerator. Okay, now let's look at the denominator. So in that case, I have 4y squared minus 4y minus 3. Okay, 4 times negative 3 is negative 12. Do I have factors of negative 12 that add to negative 4? Well, I would say negative 6 and 2, right? Negative 6 plus 2 would be negative 4. Negative 6 times 2 is negative 12. Okay, so in that case, I want to rewrite the middle term. 4y squared minus 6y plus 2y minus 3, right? And then I want to factor by grouping. In the first group, I can take out 2y, right? So I'm left with 2y minus 3 plus, and the second group I can't take anything out, right? So 2y minus 3 is still there. Now remember there's a little 1 out front there, right? 1 times 2, 2y minus 3. Okay, so 2y minus 3 is still common to both of those terms, right? So I can factor it out now. So I have 2y minus 3 times what's left over, 2y plus 1. Okay, get those separated there. Okay, so then I have 2y minus 3 in the denominator times 2y plus 1. Okay, now what can go away here? Well, 2y minus 3 is gone, and I'm left with y plus 5 divided by 2y plus 1. Okay, now what's the domain restriction? So yeah, that's another good question. So when I've got something like 2y minus 3, if I'm canceling that out, what makes that 0? So I've got 2y equal to 3, y is equal to 3 halves, right? So I would say y cannot be 3 halves. Yeah, in the final answer. Okay, so sometimes you need to do that. If it's just a linear factor with a leading coefficient of 1, it's easy to see, what's going to make that 0. Sometimes you got to set it equal to 0 and ask yourself, solve that. What is that? Okay, so our final simplification here is y plus 5 over 2y plus 1, where y cannot be 3 halves. Okay. Now, let's look at this other one. We've got negative 7x plus 8 minus x squared all over x to the 6th plus 2x to the 5th minus 3x to the 4th. Okay, so the first one thing that I like to do, I like to have the x squared term out front, and it's got a negative in front of it, so that will come with it. So I'm going to have negative x squared minus 7x plus 8 in the numerator. So in the denominator, I'm going to get started factoring. So I notice that I've got some pretty big exponents there. So I'm asking myself, what is the greatest common factor of all of those things? And I'm going to say x to the 4th, right? Because I can factor out at least that much from each thing. So if I factor x to the 4th out from x to the 6th, that's going to leave x squared, right? If I factor x to the 4th from x to the 5th, that's going to just leave x. And if I factor out x to the 4th from 3x to the 4th, that'll just leave minus 3, right? Okay, so this is already looking a little bit better, right? In the numerator, I'm going to factor a negative out. So I have negative times the quantity x squared plus 7x minus 8 all over x to the 4th times the quantity x squared plus 2x minus 3. Okay, so now in the numerator, x squared plus 7x minus 8, factors of negative 8 that add to 7. I'm going to say positive 8 and negative 1, right? 8 minus 1 is 7. And then in the denominator, I've got x to the 4th, but then that other trinomial, x squared plus 2x minus 3, that will also factor. Factors of negative 3 that add to 2. Well, positive 3 and negative 1, right? 3 minus 1 is 2. 3 times negative 1 is negative 3. Okay, so now let's look at what we have here. We do have a common factor that we can cancel, right? So we'll have negative times the quantity x plus 8 all over x to the 4th times x plus 3. And we would also say that x can't be 1, right? Because that's what makes the factor of x minus 1 0, right? All right, so now if you've got a lot of factors like this, you can leave things in factored form when you're done. So hopefully you're getting the feel for this. The actual simplification process, once you have everything factored, is not difficult, right? It's the getting everything factored and in its proper place first that is the challenge, okay?